Let's take a look at Chapter 3, problem number 154. A 260-pound force is applied at A to the rolled steel section shown. Replace that force with an equivalent force-coupled system at the center C of the section. Step 1. Your first step in any statics problem is always to draw a free body diagram and take note of any given values, assigning a shorthand to each. For our example, we can call the 260-pound force F1, denoted as F1 equals to 260 pounds. Step 2. A good next step would be to figure out what angle F1 is acting at. We can do this by noticing that F1 is a hypotenuse of a triangle starting at point A and ending at point B. Since we know that tangent theta equals to opposite over adjacent, it means that theta equals to an inverse tangent of 6 over 2.5, which gives you 67.38 degrees. Since there is only one external force acting on the steel, then we know that the force at C will also be 260 pounds at an angle of 67.38 degrees. Now that we have found the forces of the force-coupled system, all that is left to find is the moment at point C, which is denoted as M sub C. M sub C is equal to the cross product of the force and the position vector at which it is applied from point C. The position vector will be denoted as R parentheses CA. Step 3, let's find the distance first. To do that, we first need to write down the location of the 2 points, keeping in mind that we are working in 2D, so there will be no z distance, which means that z equals to 0. So point A would be 2.5, 4, 0. Point C would be 0, 0, 0. And R parentheses CA will be denoted from the math as shown. Step 4. Now we need to find the components of F1 so that they can be plugged into our cross product. The components can be found using the following equations. F1 sub x equals to negative F1 times cosine theta, in which f sub x is negative since it is pointing to the left. F1 sub y equals to negative F1 times sine theta, in which f sub y is negative since it is pointing down. Since we know that theta equals to 67.38 degrees and F1 equals to 260 pounds, we can solve for both. F1 sub x equals to negative 260 pounds times cosine of 67.38 degrees, which gives you 100 pounds I. And F1 sub y equals to negative 260 pounds times sine of 67.38 degrees, which gives you negative 240 pounds J. So we get that F equals to negative 100 pounds I and negative 240 pounds J. Step 5. Finally, we have all the numbers we needed to find the moment MC using the cross product. And we could get MC from using the equation MC equals to R cross F, which is denoted by the math shown. And by using the math, we come to the conclusion in which our final answer is equal to F1 equals to 260 pounds at 67.34 degrees, and MC equals to 200 pound inch clockwise.